So when you recognize that there is mass and there is um, magnetic field, then mass becomes expansion. It's plain and simple. When it moves forward, the magnetic field sees it as trying to expand in that direction, and it returns with a magnetic force pushing it back. When it rotates, it's grabbing the magnetic field and trying to tighten it, and it returns by the return twist. So you end up with a dipole magnet. And a dipole magnet, which is basically just mass, is expansion. It's trying to expand. Like when a star spins too fast and they say it's going to explode, which sometimes it does. We've measured it for how fast it has to move in order for it to overcome the magnetic field that's holding it together. And then when it finally pops, it explodes, and the core of it is moving at extreme rates and very dense. And because it's dense, the magnetic field can hold it together better. And it holds that, and it lets everything else run off and scatter into space, right? But that magnetic core, that tight ball that we consider a white dwarf, is very stable. Why? Because it's spinning. Its angular momentum is extreme, and the magnetic field can contain it. It can just hold it tight, and it turns it into basically a little toroidal magnet. Magnet that feeds itself. All right, so it has a very tight magnetic field, and it can maintain that field very easily. So what happens is all that extra energy goes flying off into space because it no longer has to maintain that massive loose ball. And now it just maintains that tight little core, and all the rest of it just goes flying off into space. We see this on the atomic scale, and we get confused because we see all these protons and neutrons and electrons and quarks and whatever, man. We broke it up into 17 fields, 20 dimensions, and all this other stuff, and 200 something particles, and we just keep adding more particles and dark matter and all this other stuff to try and explain what is universally seen throughout the entire universe. Mass is charge.